Hi, everyone. My name is Jim Nicely. I'm a solutions architect at Yugabyte. Thanks for joining my DSS session today. And today we're going to be talking about Yugabyte D and how it makes open source much easier in Yugabyte. So let's get started. Here's a little picture of me. Um, so is Yugabyte open source? Right? I get asked that question a lot. And yes, starting in version 1.3, YugabyteDB is 100% open source. YugabyteDB is licensed under the Apache 2 um, licensing, and the source code is actually available out on GitHub. And there's a link up there that, once you get the slides, you guys can go check it out if you want to actually look at the source code of Yugabyte and contribute. But sometimes you might think of if a project's open source, what does that mean? Am I limited on the features that I have available? And no, that's not true with Yugabyte. We it, the open source version of Yugabyte is the full featured enterprise feature set. So you get things like the Postgres API, the CQL, the Cassandra API, incremental backups, point-in-time recovery, sync and asynchronous replication, full ACID transactions, read replicas, and just a bunch more features. So that you don't have to worry about open source with Yugabyte, right? And so the question, like why would we want to open source? And that kind of basically just boils down to it's almost like a collaboration, right, with community where folks are using Yugabyte, giving us feedback, positive and negative, right? And that helps us build a better Yugabyte. And it's kind of like I drew a little feedback loop down at the bottom, right? So as as people are using Yugabyte, we get the constructive feedback, and then we build a better Yugabyte. And what we found like is this having it open source just removes the barrier of a or a customer or someone who just wants to try it, right? So you don't have to worry about getting an enterprise license or whatever. You can actually just go out and download Yugabyte and get started right away. So we found that this is a great way to get the community going with Yugabyte. So real quickly, um, there are kind of like three deployments of Yugabyte. So we do have a fully managed service. We call it Yugabyte Managed, and then we also have another product line called YugabyteDB Anywhere, and that's more self-managed by a customer. But what we're talking about today is on the right over here. It is the open source version. It's just called YugabyteDB. But again, you're going to get all the full features of these, except these guys over here give you a nice GUI and a way to manage it, through a nice web page. So you can manage multiple clusters. Whereas we'll find out over here with the open source, there's a lot more scripting that has to be done, lot more manual steps that as a user would take, but it's still fully featured once you get it up and running. And we'll see that we can get it up and running really quickly. So um, here, how do you download Yugabyte DB? Really easy. You just go to downloadyugabyte.com. Right, I highlighted the Linux version of it. You can actually, if you have a Mac, you can install right on a Mac or Kubernetes or within the Docker containers. But real simple. I've already installed this for the demo that I'm going to present, but this is basically all you have to do to get started. And if you look at the commands down here, right, you'll actually see Yugabyte D is one of the commands to get started. So this is a simple way to get started. So you can be up and running in seconds. But let's first talk about what, all the versions of Yugabyte have these component services, even the open source version. So there's two servers that are running on a machine on a node. One is called the tablet server, and one is called the master server. The tablet server is responsible for all the I/O operations like read and writes, whereas the master service is responsible for metadata type operations like the catalog and like what columns are in the table, what are the primary keys, stuff like that. So this is an example of a 4-node cluster. You're probably familiar with Yugabyte, right? We're a cluster of nodes. So a database is a cluster of individual nodes. And on each of these nodes are these servers running. We only need 3 masters for high availability, but each node is going to have a T server. because that's where you're going to be connecting to actually run your queries. So that's why you see 4 T servers here, but only 3 masters. So if you're familiar with running Yugabyte OSS in the past, or um, actually since its inception, right there are command line tools. One's called YBmaster, and it's used to actually start a master process. And I just showed a real quick example here of the minimum required flags to start a master on a node. And you'll see here, yeah, so we have to give it a placement, to kind of like give you a cloud, a region, and a zone kind of directory where you're going to put your log files and your data files. And then, of course, an IP address. And here I'm just using the loopback address. It's the same with the T server process. There's a minimum set of parameters you have to pass in, and these are them. There's many more that you can also use, but this is just the minimum to get you up and running. And this is what you've done in the past if you're running OSS, right? You're on each node, you're actually starting these processes manually, and then having to join the cluster together all through these manual steps. But there's a much easier way, and we call it YugabyteD. It is a daemon that is running in the background. That it's actually a wrapper around that T server process server in the YBmaster server that we were just talking about. So you still have the same processes running, the YBmaster service and the YBT server, but it's just one command now, so you don't have to worry about multiple commands. And we'll see how easy it is with that one command to add nodes to a cluster, um, so that you can horizontally scale your database really easily. But it has some other cool features, right? So when you run Yugabyte it does some preliminary OS checks to make sure that you set all the parameters, like the OS parameters, correctly. It'll give you warnings about that. And it also has a nice little UI. Like I mentioned YBM, our managed deployment model, and then YB Anywhere. Those have a nice GUI, right? But there's also a GUI for Yugabyte that I'll show you in a bit here. But real quickly, here's an example of how easy it is to start a single node database, right? So I've downloaded Yugabyte from downloads.yugabyte.com, and I just simply run yugabytd start. And what it does is it starts up both that T server and the master service in the background, and you get a nice little status down here of what it looks like. So you'll like the status here says running. It also has a replication factor. Remember, Yugabyte for HA, we would want a minimum replication factor of 3, and we'll see how we get to that by adding nodes to this cluster. And then here's the UI I mentioned, so you can get to it through a web browser, and a few connections strings here. You can see that YSQL and YCQL are both supported, and it automatically it set a lot of defaults for you. So if you don't specify a data directory or a log directory, it just manually puts it in these directories, and that's all configurable. So what I wanted to show here is I mentioned that Yugabyte is a wrapper, and to kind of show that, it's actually a Python script running. So if I just do the pit of Python and I can get the process ID of it, and then check out all of the child processes. You'll see that a child process is YB master, the YB UI, the YBT server, and then Postgres, which is used for the YCQL. So basically, this one Yugabyte is now a wrapper for all of these separate processes for you, which makes it much easier to install if you have 3 or more nodes, because it can get quite cumbersome if you're trying to manually run the YB master and YBT server yourself. But so as easy it was to start, it's also just as easy to stop, right? So I just say, instead of Yugabyte start, I say Yugabyte stop. And what it did was it created this config file, this Yugabyte config. So all of the configuration information that it used to start that is kept there. So I can easily just start it again, or I can run this Yugabyte destroy command, which will now delete all of this information. So this is just a quick test But I will say be careful with this destroy command because it literally deletes data. So just make sure when you run that you mean to run that. And at the command line, if you need help, YugabyteD has a -- help. Will get you all of the commands that are available with YugabyteD. We already saw start and stop and destroy. Status just brings up that nice little status of what's running. Version we'll see gives you the version, and there's a couple other different things. So we'll actually be using some of these in the demo. Real quickly, here's the I just wanted to see what version I'm running. So it's 2.19.2. This is a more current version of Yugabyte D. So we already saw how easy it is to set up one node, but typically you're going to want to have a multiple number of nodes in your cluster, right? Because that's the whole point of Yugabyte is to be resilient. So you want at least 3 nodes to do your testing. So how do you do that with Yugabyte D? Again, we're going to issue a Yugabyte start command. This time I'm going to pass in an advertise address, which is going to be the IP address of the node that I'm on. And then I'm going to give it a base directory here. Just call it root. It could be anywhere, right? So I'm just putting in this node 1. But I'm redirecting the output to a log file here because I didn't want to see all of that information on the screen, right? So I'm just directing it to a log file. And then once this completes, I'm actually going to connect to this node using the YSQL sh CLI, and then I'll just pass in this simple SQL command querying this. We have a function called YBServers, which returns the IP address of all of the hosts in the database. So when I run it this time, I only get one node, and that's the node I started. But now I want to start another one. And again, this is all on one machine. And this is great for testing, right? So I'm actually doing a multi-node cluster on a single machine. So this could be my Mac, but I'm actually all of this code here is actually on a VM in the cloud, right? So, but the point is, I'm trying to set up a cluster to do some testing, right? So I want to do some quick testing of Yugabyte features. So instead of having to stand up, expensive cloud VMs to do that, I can just do it this way and save on infrastructure costs for my testing. So uh, here in this, we're going to see here how we're starting a second node. So it's the same Yugabyte start. I'm running this on the same node, right? If this happened to be a separate VM, I would be running the command over there, or you can run it via an SSH command and just pass the command to the SSH. But here, so I'm using a second IP address, which is also a loopback. Notice that the base directory is node 2 now, and then there's a special parameter here called join, and I'm telling this node to join the node that I already started up here. And again, I'm outputting it to a log file, and then if I run that same SQL command, this time I get back 2 IP addresses because now there's 2 nodes in the cluster. And then the same thing down here. I'm adding a third node. Again, I'm joining to node 1. And then I run this command again. YBServers is going to return 3 rows. Since I'm using string ag, it's aggregating this host up into a single line. And you'll see now I have 1, 2, and 3 in my cluster. So that's the neat thing about, you've probably done this, like I'm just using this loopback to have kind of fake IP addresses all on the same node. So Yugabyte is able to do this for you. It could do it on the Mac and on VMs as I'm showing here. Remember I mentioned the replication factor. So the replication factor is important in Yugabyte, right? So you want to have replicas of your tablets for HA. So as I was adding those nodes, remember I was outputting to these log files. And we see the replication factor is 1, 1 when I add a second node, but it switches to 3 automatically when I added that third node. So that's a feature of Yugabyte D is as I go to 3 more nodes, the RF will be 3. And you can override that later on if you want to do an RF5. But for this right here, I'm just doing RF3. And one other thing I wanted to show you, that YBServers function I mentioned, we were just looking at the host column before. But if you look at, there's three other columns that kind of like tell Yugabyte where the node resides. It's called cloud, region, and zone. And by default, cloud is always cloud one, region is data center one, and zone is rack one. So this is kind of what it looks like if you don't set these parameters. So the bad thing about that is all nodes are in a single AZ. So if one of those nodes would stop, I'm not getting any HA here, right? So what I want to do is to have placement blocks that are either in different regions or different zones. So out of the box, YugabyteDB is supporting node level fault tolerance, but not like a region level. So if a region would fail here, like data center one would fail, right? It's just going to take my whole database down. So we're going to see quickly on the next page, actually, how we're going to override that. But if YugabyteD has a configure data placement, so, and I'm telling it the fault tolerance I want, the fault tolerance is a fault domain. So what this means is if I have three replicas, I'm going to want a replica in each fault domain. So this here is my fault domain is zone, and here's fault tolerance of region. This is what the demo layer is going to be, right? We want to have a region level failure. So this is a command that you run to tell Yugabyte D that my fault domain is at the region level. So I just real quickly, like this is kind of a neat feature. Yugabyte has a built-in demo database. It's the Northwind database that you're probably familiar with if you ever work with Microsoft databases, right? Northwind is super popular with them, and so you can install that database and a data set with a simple Yugabyte demo connect. And just give it this base. It could be any of the node base directories, and it'll install the database, and then you can start running queries right away. But this is just if you want to kick the tires around a little bit. Typically, you're going to want to create your own database, your own tables, and your own data. So we had that 3-node cluster. So I just kind of want to show here, I have to run 3 individual stop commands and then 3 individual destroy commands to get rid of this. But there is a better way of doing this. And I mentioned that, if you're using open source, you're going to have to do a lot of scripting. And so I just have these real simple scripts here. I have a stop all shell script that simply goes out, stops all of the nodes for me. And then I have a destroy all. So this is the kind of stuff that you might have to do when you're using Yugabyte in open source. So we're gonna do a little demo, get a little more complicated, because I want to show you that using Yugabyte, you're not limited on enterprise features. It's fully featured, so some of the features we're going to use are pretty advanced, but we can do all of that within Yugabyte. So this is a typical 3 scenarios for deploying Yugabyte. We have a single region multi-zone. Remember, I talked about these fault domains. So each of these fault domains will have a copy of the data so that we can have a failure of one of these and the database would still be up. And then the next level at a more resiliency would be at the region level. Again, here, a copy in each of these fault domains, which is a region. And if a region would go down, your database will stay up. And then we also have a multi-cloud multi-region, right? It gets more complicated. So, you're actually spreading your database across clouds. And the interesting thing is you can do all of this with Yugabyte. We're going to do the center one, but you can do a multi-cloud with open source. So here's the layout we're going to try to build in Yugabyte. We have 3 regions. Actually, this is a hybrid kind of a solution. So there's 2 data centers that are kind of local. I just call them DC1 and DC2. And then I have 1 cloud region. It's just US East 1. And then we're going to do a bunch of advanced features, right? So we're going to have a total of 9 nodes, 3 regions, 3 nodes per region, an RF3, and again, a fault domain of the region. But we're going to do crazy things like geo-partition, duplicate covering indexes, follower reads. These are all really cool enterprise level features that we're going to be able to use with YugabyteD. So these are some of the requirements like we're going to try to enforce, like local reads to data center one, local reads and writes to data center one, and then follow reads, right, to get super fast response times. And then the application user is going to come in through either the DC. There's actually 2 application servers in this demo. One's coming in from DC1 and one's from DC2. Again, back to the scripting piece of doing this. So I didn't want to create 9 nodes manually, so I created this shell script, right? This is called start all. And what it's going to do is it'll start the first node, and then it'll start the remaining nodes in parallel. So I'll issue a start command, one start command. You have to wait for the first node to come up, and then I can join. I can start the 8 remaining ones in parallel and just run through a loop until they're all up. That's kind of how this works. And then down here at the bottom, I'm doing the data placement and telling it the fault tolerances region. So this is kind of how it looks when I'm actually going to demo this for you. So we'll switch over. So I'm running the command start all.sh, and I'm passing in, the way I set up the script was I had to pass in the name of the first node. So this is just the name of my node. This could be an IP address too. So this takes less than a minute to stand up. Again, right now it's starting the primary node. This is typically the longest piece of it. Okay, now I'm starting the 8 remaining nodes in parallel, but my script had a little 2-second sleep in between each of the starts, just to keep it a little bit cleaner. So this should come up in about a minute. And once it's up, we'll have a fully functioning 9 node cluster. All on this is all on the same machine. This is the reason I really like using Yugabyte is, right, so I can do something like this and be able to test these really advanced features locally, without having to stand up a 9 node cluster in AWS, for instance, right? So that could be pretty cost intensive if I just want to be testing these features. So now we see we have our 9 node cluster up. And then I have some commands here, so I will grab this guy. And again, I'm querying my YB servers function. This time I have 9 nodes. And then I overrode the names of, remember, the cloud, region, and zone, how they defaulted to data center 1, AZ1. But now I've overridden them and just called them. These can be anything you want. You can call, you can be creative. Like, typically, if it is a real cloud database, you're going to call it AWS or Azure or Google. Just be descriptive so that later on you'll know where this node is. And these are my on-prem data center guys. So now I have my 9 node cluster up. And this is what we just showed you. So there's a curl command I can run. And I'm hitting this Yugabyte. Remember, I called the first node YugabyteDB.tech was the name of the server. So if I curl port 7000 and look at this cluster config, I can get this output here. And this is showing me how the cluster is set up. You can see now these placement groups are across regions. Before we had created that 3 node cluster, it was all in one placement group. Now these are all in 3 placement blocks. So now we're safe at the region level. Yeah, I always do this like on my Yugabyte. Anytime I'm working with Yugabyte, I edit the bash underscore profile. I always put the bin directory in the path, right, just to make it easy. But I also create aliases. I call them Y and C. You can call them whatever you want, but like Y quickly allows me to launch YSQL sh, and then the YCQL is I alias as C. And you can see if I just click Y, it brings you right into Yugabyte. And here I want to quickly show you what the GUI looks like. So YugabyteD has a status command. If I just do a status and I grep for Yugabyte UI, just in case I forgot what the address is, I can get it this way. So it's HTTP and then the name of the node, and then it's using this 15433 port. So these are ports that you're going to have to make sure that are open if you want to get to this UI. And it's simply a web browser, and it's pretty handy. You can't create nodes or destroy nodes or add nodes with this. It's more or less a reporting kind of tool, but it's still super handy. And there's also two other UIs. One's running on 7,000 port 7,000. So this would be the master UI. So it's going to give you information about the master service it's running. And then there's a T server UI, and it's running on port 9,000. Again, so each node, you would have to run the command on each node to get visibility, at least for these two. For this guy, the YugabyteD UI actually does cross nodes, so it's nicer than these two, which are individual nodes to get information. So going back to the demo piece here, um, here's here's our setup. Just want to remind you real quickly what we're trying to build here. So how do we go about doing all of that cool stuff with YugabyteD? If you're familiar with Yugabyte, you're going to be familiar with YBadmin, and that's a tool. It's just another CLI that does admin features, like list all masters, for instance. So to run those type of commands with YugabyteD, you can use YBadmin, but maybe you don't want YBadmin available to a developer or something like that. So they only have YugabyteD, for instance. So in that case, they can run YBadmin commands. It's through this configure admin operations command of Yugabyte, and then you just pass it in the command. So what I'm doing here is I just want to get a list of the masters in my cluster. And remember, I have 9 nodes, but there's only 3 masters. And the way it works is, since I have 3 regions and the fault domain is at the region level, each region will have a master. So we see Yugabyte Tech has a master, right? It's the leader, and then 6 and 9 each have a leader master. Excuse me. So what I'm doing here is an advanced feature of Yugabyte is called preferred regions. And the reason you would want to do that is you want to put leaders in a region where the application is hitting, because those leaders are responsible for reads and writes. So you want the latency to be as low as possible. And again, I can do that with Yugabyte using the configure admin operations. This time the command I'm passing in is set preferred zones. And I'm making DC1 and DC2 level 1. So those are my preferred regions, whereas the AWS region out here is 2, so it's secondary. And you can see that, remember the curl command I mentioned? There's another section of the output there of my cluster config called multi-affinitized leaders. And in there, since I ran that command, you'll see these two are grouped together up top, meaning that they're preferred. And then this guy down here is, all by itself and not preferred. So we're going to continue with some more advanced features, table spaces. And what we're going to try to do is isolate data to a particular data center through these create table space commands. So let me go back here. Remember, I can type Y to connect to my database. Let me scroll down to the table space block here. So I'm creating 4 table spaces. This is actually a feature of Postgres that Yugabyte uses to let you localize data in a particular region. I'm creating these 4 table spaces. The first table space is going to be localized to DC1. So we're creating these 4 table spaces. The first table space up here is localized to DC1. This table space is going to replicate data across all 3 regions. This guy, excuse me, DC2 table spaces again. I'm sorry, let me restart this. So we're creating 4 table spaces. The first table space up here is spread out across the entire cluster. And I'm setting the preferred leaders to be DC1, DC2. I'm sorry, DC1 is a preferred leader for DC1 table space. Secondary is DC2, so my second replica is going to go here. And then the third replica will go out to the AWS region. And for this guy, I'm creating a single region table space so that all of the data will be localized to a DC1. And that's the same here with DC2. I'm creating a localized version and then a full cluster version. So I'll just run these commands real quick. So all my table spaces are created. So we're going to load some data into our database. For that, we're going to need some helper functions. Basically, it's a Postgres extension here that creates random UUIDs. Another function does random integers, and another function does random strings. So let me create those. And again, what I'm trying to convey is the fact that you can do all of these advanced features like table spaces. You can create stored procedures. You can create extensions. This is all using YugabyteD. So now we're going to create some tables. I'm going to create a partition table, right? Another advanced feature. And then for the partitions, we're going to actually put them into DC table or into the table spaces. So for this first one, I'll be putting into the single region. For this test geodc2, it will go into the table space DC2 single region. And then I'll insert some data. The cool thing here is this DC column, which is the partition column, it's defaulting to this function called YBServerRegin. So we created multiple regions. So whenever I insert data into this table, this DC will default to whatever region I'm in. This is the column used for partitioning, right? So if I do a where clause, where DC equals DC1, it will know to use this particular table space. So let's go over and just create these tables and then I'll go back and grab the next. So I'm doing 2 different inserts here. The first insert, I'm specifying DC1. The second insert, I'm not going to specify DC2 because I want it to default to the region. And if you see here with my command, my YSUSH, I'm actually connecting to a node that's in region DC2. So it'll know how to default. So my partition tables are created. I'm inserting my data. And then real quickly, we can see our data is inserted. Notice that the DC2 was populated automatically. The DC1 was populated because I forced it to do that. You can also query directly from the partition tables. We won't do that. So I'll quickly show you here, like if I run this where clause on a query, we should see the explain plan should show me that it's querying from the partition that we specified, and that's the case. So what's happening in here is I'm getting local reads from this DC1 table space. Another advanced feature is something called role level security. And here, I'll show you. So yeah, so this is querying directly from the partition tables. So you can see if I query from the partition table, just DC1 comes back. Same with DC2. And we verified that partition pruning is happening, right? So when we do a where DC equals DC1, it will partition prune, right? It's not going to read any data from this partition, just that partition. Okay, yeah, so row level security, I love this feature. Again, this is something you can do in YugabyteD, which is awesome. And what this does is it'll dynamically apply a where clause to a query that's running. In this case, I'm going to dynamically say where DC equals YB server region. So whatever region I'm connected to, there's going to be a where clause tagged onto my query, so that I'm only going to be querying the region data that I'm in. We'll show you that. So I'm creating an app user, and then the security policy. So now if I run YSQL SH and I connect to node 1, which is region DC1, and I'm actually selecting YB server region, the -C allows you to run commands from the CLI, but I'm going to select asterisk from the main table as that app user. And what you'll see is just DC1 rows come back. And it's the same if I connect to a node in region DC2. In that case, DC2 rows just come back. And if I query from the AWS region, nothing comes back. And that's kind of that's what I wanted to have happen. The reason I wanted that is because I wanted the applications to be able to quickly read data from their prospective data center. So I know I went through that really quickly, but I just wanted to show you that with YugabyteD, all of these advanced features are available to you, which makes testing really easy. So say there's a new feature in Yugabyte you wanted to try out, you can just download Yugabyte, get a database up and running, and do your testing. No special licensing required for these features, right? So that's the point I wanted to make, right? So it reduces the burden on new users, right? We want people to use Yugabyte, right? So how do you do that? You give it to them for free. It can be installed in minutes. You saw I had that nine node cluster up in less than a minute. You get both Postgres and Cassandra, so you can test both APIs. You can deploy single node, multi-AZ, multi-region, or multi-cloud, or like we did, a hybrid database. Again, super powerful way to test stuff. These table spaces, we did partitioning, RLS, and follow reads, but anything that Yugabyte does, you can do with Yugabyte. And then we get that nice UI, and the final bullet point there, it's free, right? So I highly recommend it if you wanted to try Yugabyte. All you have to do is go to this link down here, and it's available for you to download and give it a try. And I just want to thank you. Thanks for listening to me today. I hope you learned something about Yugabyte and give it a try. Thank you.